Hello again, everyone. This is Mr. Vigil. Today we're going to be talking a little bit about polynomials. And so, first off, what a polynomial is, or what the word means. Well, the prefix poly, of course, means many. And the word nomial is actually going to be referring to terms in this case. So polynomial means many terms, and terms are things that are added together, so that's really all this is, a bunch of things added together. But for polynomials, these terms are going to look a certain way. So within a polynomial, terms are always going to look like this. Some number a times a variable x raised to some power n, where n is a natural number, really a whole number. Could be 0. But that's how they look, just some number times x to some power. And a whole bunch of those different things with different powers, their n, all added together. Now, one thing about these things, we have what's called a degree. And the degree of a term is nothing more than the exponent on the variable. So if x is being raised to the power of 2, then that's a degree 2 term, or of second degree. If we have a whole bunch of terms added together in a polynomial, then the degree of the entire polynomial expression is going to be the largest exponent. So, for example, suppose we had a polynomial expression like this. 5x cubed plus 8x squared minus 3x plus 4. So this term right here, this is really, we could think of this as 4 times x to the power of 0, because anything raised to the power of 0 is just 1, and 4 times 1 is 4. This term would have degree 1. So here's degree 0. This has degree 1 because x is really also just x to the power of 1. This term has degree 2 because x is being raised to the power of 2. This term has degree 3 because x is being raised to the power of 3. So degree 0, degree 1, degree 2, degree 3. Those are the terms. But since 3 is the highest degree, this entire polynomial, we say it is a third degree polynomial, or of degree 3. We also classify polynomials by the number of terms in them. So this one has 1, 2, 3, 4 terms. Okay? So this is a third degree polynomial with 4 terms in it. Now, certain numbers of terms and certain degrees have special names which we want to use so we don't sound goofy when we're talking about these things, and we can all communicate clearly. And they are these. So a 0 degree term, or a 0 degree polynomial, is going to be a constant. So this term is called the constant term. Okay? Because it doesn't change, it's constant because it doesn't have a variable in it, so therefore it doesn't vary. A first degree term, or a first degree polynomial, is called linear. And if you think about that, well, cover this all up. Degree 1, this is of course negative 3x plus 4, that's a linear expression. Just like when we did linear equations, y equals negative 3x plus 4, there we see it. Degree 2 is called quadratic, so this is the quadratic term. Or if we looked at an entire polynomial, which with degree 2, where 2 is the highest power of x, this is obviously a quadratic expression, which you've looked at before. Now we're going to extend it out a little bit more. If we have a third degree term, we call it cubic. That would be this term right here, the 5x cubed. Or we say that this entire polynomial is cubic. There are some other ones, quartic for 4th degree, quintic for 5th degree. We never use those really, we just say 4th degree, 5th degree, and so on up 6th degree, 7th degree. For the number of terms, if we have one term in the polynomial, it's called a monomial, not a uninomial or whatever that might be, but monomial, because mono means one. 2 terms, we call it a binomial. 3 terms, we call it a trinomial. We don't really name it anything beyond that. We just say, oh, it has 4 terms, 5 terms, 6 terms, and so on and so forth. But monomial, binomial, trinomial, you're going to hear those words a lot, so I want you to be familiar with them. Okay. Now, we have what's called standard form for a polynomial expression, and that basically looks like this, like we just had it. The terms are written from highest degree to lowest degree from left to right. And also we have to combine all the like terms. We don't want to see 2 terms in them with both having x squared, because then we can combine them. Meaning we just want to simplify these things. A polynomial is never going to have any parentheses. We have to do all distributive properties and then combine all the like terms. And then we write the polynomial with highest degree to lowest degree, left to right. So for instance, simple example, if we have 6x plus 3x squared minus 2, this is not in standard form because we have a first degree, second degree, and then a 0 degree. So all we want to do here is just apply the commutative property and write it from highest degree to lowest, 3x squared plus 6x minus 2. And that's how we saw it, standard form for quadratics, of course, because quadratics happen to be an example of a polynomial. Pretty simple there. Now, if we are adding or subtracting polynomials, yes, we can do arithmetic with these things. It's pretty simple. If we're adding or subtracting, all we have to do is combine the like terms. So if we have something like this quadratic, and we're subtracting off this other quadratic, well, we have to be a little bit careful, especially with subtracting, because we're not just subtracting off this first term, we're subtracting off all of these terms. So we might want to switch this up and distribute that subtraction in, or switch it to plus the negative of the next thing, and then distribute in that negative sign. So this thing is actually going to be 5x squared. We could even, I don't like negative signs because they're easy to lose. We'll call this just a plus negative 3x. Make sure we can actually see that in there. 5x squared plus negative 3x plus 7 plus, we're distributing this in, and now everything's going to be, we don't have to worry about the subtraction, so we can drop the parentheses. Negative 2x squared plus negative 5x minus, oh, I forgot to switch this one around, plus negative 7. So it's plus the negative of negative 7, which is, of course, positive 7. And now, pretty simple, we just combine the like terms here. 5x squared is here, negative 2x squared is here, leaves us with 3x squareds. Negative 3x is here, negative 5x is over here, so that's plus negative 8x's. And then 7 here plus another 7 here for our constants. Add those together, we get 14. Pretty simple. We could, of course, switch this around to minus 8x, but it's completely unnecessary. If you want to leave it as adding the negatives, I'm totally fine with that. Because once again, I hate subtractions. But that's pretty simple. That's adding or subtracting. Also, we can multiply two polynomials together. And just like adding or subtracting, we've seen this before. This is nothing more than simplifying. But when we're multiplying two polynomials together, all we're going to do is just apply the distributive property. Here we can distribute this polynomial, this linear polynomial, 2x plus 1, to each of the terms in this quadratic polynomial. And so this is going to be equal to, start down here, just leave myself some room. We'll have 2x plus 1 times the x squared. I show that we're going to distribute this whole factor of 2x plus 1 to each of the terms in this one. We might also want to switch this to plus negative 2 so we don't lose that. So it's 2x plus 1 times the x squared plus the 2x plus 1 times the 4x plus the 2x plus 1 times the negative 2. Let me put it in parentheses here just so we don't accidentally think that negative sign is a subtraction. We're multiplying by negative 2, not subtracting 2 from it. Now, well, we've got more parentheses in here. We still need to simplify. So we're going to distribute each of these factors now back into each of these 2x plus 1s. So the x squared will go to both of those guys. The 4x will go to both of those guys. And this negative 2 will go to both of those guys. And we've seen this kind of thing before when we're just multiplying out stuff. It's really just simplifying. Again, bit of review. So x squared times 2x is going to be 2x cubed plus x squared times 1 is just x squared plus 4x times 2x is going to be 8x squared plus 4x times 1 is 4x, plus negative 2 times 2x is negative 4x, plus negative 2 times 1 is negative 2. Now, we've gotten rid of all of our parentheses by applying the distributive property. Now all we have to do is combine the like terms. This is the only degree 3 term we have. So we have 2x cubed. We have x squared plus 8x squared. That's 9x squared. 4x plus negative 4x, those cancel out, and that's just 0. But we do have our constant term out here, plus negative 2. Nothing more than just simplifying, and we'll get a bunch of practice doing that in class. And so, I'm going to leave you with a couple of practice problems to do before you get to next class. So simplify those, double check your work, and have them ready to show me at the beginning of class next time. Thanks for watching.